Hello, this is Ian Kilborn, Energy Systems Engineering Technology at St. Lawrence College, Kingston, Ontario, Canada. Okay, this is a video on RETScreen Expert and how to do air leakage modeling in the building envelope section of RETScreen Expert. So here I am in building envelope. I've modeled two simple zones here. The first one has some walls in it with an R value, and down here I've got user defined. So natural air infiltration is where we're going to put our air leakage. I have user defined. There's a number of choices here. When you first open up, the default you will see here is calculated, and it shows everything as leaky. That's the default. Calculated figures out what it thinks the air change rate is going to be based on what you've modeled up here for the rest of the building geometry. The actual math that it uses to figure that out is not clear, but it does something. You can see here it's decided that we're going to have 400 liters a second based on what I've got up here. If I go over to zone 2 here, I've got the same thing, the default leaky, 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 but I have no building geometry, whatever, modeled. If I come up here and look under include measure, you can see that there is no energy being used in zone 2, even though the air leakage is listed as leaky. That's because there's no building geometry or other building envelope features in there at the moment. If I go back to zone 1 here, another interesting thing happens. If I choose user defined and leave that as 0, I'll come over here, leave that one just the way it is, come back to include measure, and you can see now that zone 1 building envelope doesn't even have a 0. It's not even calculating any heating, even though in zone 1 I've got a bunch of walls with R value, and they should be creating a heat load. They're not, because I have nothing down here. If I put in zeros down here, I'll click this to copy across to proposed. Come back here. Now my building envelope is showing some heating load. The heating load that it's showing is going to be caused by these walls here. And so you have to be careful what you're doing down here, because it will affect your results a lot. If I just wanted to know the heat loss associated with my walls, this is what I would do. Put in user defined, set it to 0. That means we have no air infiltration, and it will go ahead and do the calculations. So if I have some blower door data, this is where I'm going to enter it down here. And so blower door data gives us air change rate. We're going to enter the volume of the building here, and we can do that in cubic meters or cubic feet, whichever we prefer. And air changes per hour. From our blower door software, we're going to get ACH 50. That's air changes per hour at 50 pascals of pressure difference. 50 pascals of pressure difference happens when you have a great big fan in the door. The ordinary, everyday air infiltration is going to be much less than that. That's why it's called natural air infiltration here. So we have to convert from our ACH 50 to something that's more what the house is going to have from day to day. Of course, houses that have a large ACH 50 will also have a large natural air infiltration because they're very leaky. So there's a correlation there. A simple way to convert from ACH 50 to ACH natural is to divide by 15. So if my ACH 50 was 15, a very leaky house, my ACH natural would be 1. Most of my ACH naturals are going to be less than 1 in this model. There are more accurate ways to do that than just dividing by 15, and there are some papers on the internet that you can find that will describe a method to do that that depends on the height of the building and the windiness of its location and the weather region in which it's installed. If you're taking one of my courses at St. Lawrence College, I will provide that paper to you. For the moment, we're going to divide by 15, which is a reasonably good place starting. Most of the calculations you'll do, if you use the more accurate method, will get you numbers like 12, 13, 15, 16, in that range. So I've put in my air change rates here, half an air change per hour. That's my natural rate. I got that dividing by taking my ACH 50 and dividing it by 15. RETScreen then calculates the liters per second. If I come over here to include measure, I can see now that my energy consumption has gone up quite a bit caused by that air leakage. I can come back here and see exactly how much that was. If I set this air changes per hour to 0, then I can come over here. This is the proposed case. I can come back here and I can see that my fuel cost savings is this much. It doesn't show me the kilowatt hours over here. If I come over here, I can kind of see a little bit more exactly between base and proposed. What's the difference? So $31 as compared to $75 has been saved by eliminating the air leakage. So we can see that the air leakage was worth about $40 in savings. So when you have created multiple zones for your building, you have building geometry on every zone, and the default, remember for this, is going to be calculated, and it's going to look like that. This will overstate your air leakage tremendously. If you have blower door data, then just put your blower door data. Typically, you just need to put your blower door data on one zone, unless you really want accurate readings on zone by zone of what leakage is. If you're just trying to do the whole building, you can put your air leakage all on one zone, and if you set it to air leakage rate and model it as I was describing, that will be fine, providing on the other zones that you zero out your air leakage. So go to user defined, and set these both to 0. Don't leave them blank, but enter zeros in there. So zero it out everywhere that you're not modeling it. Otherwise, the default here will be adding air leakage on all of your zones in a very large way. If you want to proportion your air leakage according to zones, then you'll have to decide from your single blower door test how much air leakage you think you want to put onto each zone, and enter it manually in these boxes zone by zone.